Okay, my previous video was about applesauce and transformation. Please watch it to understand what we will talk in this video. This video I want to get more down to practicality of this. So in the last video we had an example that we know how much applesauce we have on a certain point on table A, and as we said, the point means that box, and we use the notation the left side and the bottom, that will, the whole box will be called that. So 17/8 means really the square. That's x is 17, and it goes from 17 to 18, and y goes from 8 to 9. That whole square we call 17/8. You want to, whatever applesauce is on that unit, on that square, let's say a half ounce or a quarter of an ounce or 1 gram, I don't care. Whatever is spilled there, we are going to push somewhere else on a different table. It's not going to be anymore on point 17/8, it'll be on a different point. So here's the question. The question will be asked in reverse, meaning to say, I am telling you on this table B point 17/8, and I want to know from where the applesauce came from. At which point did this applesauce come from? Right now I have in front of me, I see only table B, and I see a piece of applesauce, a nice big pile, a tall, like a good 3 ounces of applesauce on 17/8. I say, wow, where was this mountain originally located on table A? I wonder where it was located. Answer. We're telling you, first of all, the way it transforms from table A to table B. Now write it down on paper. You should get a hunch what we're doing here. This formula teaches us how to transfer the applesauce from table XY to table UV. You take the drop of applesauce that's on point XY, you add together these 2 points, x plus y. For example, if x is 17 and y is 8, so that's 25, that's going to be the point of U. On the new table there's also an axis called U that goes from left to right. So you put that piece of applesauce on point 25 of the U axis, and the V will be x minus y, that's 17 minus 8, 9. That's where this applesauce of 17/8 will land on the new table, point 25/9. However, we're interested in the reverse question, so we will write the formula to see what is x in terms of U and V. So by doing some simple algebra, you can see I'm writing on paper, and I'll show you how we did it. X is equal to U plus V over 2. Y is equal to U minus V over 2. Please take a look at the bottom. I made 2 formulas. X is equal to U plus V over 2. Y is equal to U minus V over 2. So to understand why this works, simply U plus V will be x plus y plus x minus y. That cancels out, so you just have 2x. 2x divided by 2 is x. Next, y is equal to u minus v. U minus v will be x plus y minus x minus y, so you get just plus y minus minus y, that is 2y. 2y over 2 is y. So this is simple algebra, how to extract the reverse. So by knowing u and v, you can see what the x and the y is. So what is this so important here? As I said, we found a nice big lump of applesauce on table Y and table UV by 0.259. So we're wondering, wow, from where did it come originally? From table on table XY, where was it? So we say, let's take U plus V. That's 25 plus 9. That's 34. Divided by 2 is 17. Yes, that's where it came from. That was the point X. Then we go to U minus V is 25 minus 9 is 16. Divided by 2 is 8. So here we have the formula. If we see a nice piece of applesauce on table UV, we can reversely figure out from where it came from table A. There's a unique point from where this jumped. As we see, we have a formula that tells us exactly. If we see something on UV, we see something, say something. We see something on UV, you can figure out exactly unique point. These numbers U plus V and U minus V are obviously unique numbers, and so I'm saying an example. Let's say U and V are 0, 0, 0, right? That's the only place where U plus V and U minus V are the same. So no problem. That came from 0, 0. X, Y also 0, 0. That's not a problem. Just to get a overall view how this will look in general. So let's imagine that table XY was smeared with applesauce from 0 to 10 on the X. I'll make a diagram you should understand this. 0 to 10 and 0 to 2. Just hold on, I'll show you how this transforms on the new table. Please take a look at the XY table. The applesauce was smeared from 0, X was 0 till 10, 0. It means that X is 10 and Y is 0. Then it went up to X 10, Y is 2, and on the other point it was X 0, 0, Y 2. Now it got onto the table of the UV. As I said, the UV table is U is x plus y. So let's see the point 10, 0 will be pushed up. U will be x plus y, that's 10, and V will be x minus y, also 10. So the point, I'll write 10, 10 here. Ten, 0 is corresponding to 10, 10. The point 10, 2 will be 10, 12. Why? Because that will be the U will be that will be 10 minus 2. I'm sorry, I didn't make the right graph. The V will be 8. I didn't do it right. The V would be 8 and this would be 12. I'm making the new how the new table will be, how we turn this table on the UV, how it will be all these 4 points. So the first point is 0, 0. Obviously that stays the same because x plus y is 0 plus 0, 0 minus 0, that stays the 0, 0. The top point 0, 2, x plus y is 2, 0 minus 2 is negative 2. So this ends up that the u axis will be by 2 and the v will be by negative 2. You can write down things nicely because you can see what's happening here, how this transformation takes place. And then there's a point that's 10, 2, x is 10, y is 2. Here it gets x plus y, so it's 12, and then we have x minus y, that's 10 minus 2 is 8. So that's 12, 8. The u is 12, and this is 8. And last but not least, we have 10, 0, that is 10, 10. Here you have the whole picture. This is the point, it's called 10, 10. It's from 10, 0. This point is 10, 2, and it turns into 12/8. Make sure you can read it nicely. Okay. It is the one that you see here. It is that rectangle that goes slanted. We see it says 0, 0, 0, 0. Then you go a little bit down, you see 0, 2 turns into 2, negative 2. Then you go to the other side, to the right side, you see 10, 0 turns into 10, 10. That's the point there on top. And finally, the last point, 10, 2 turns into 12, 8, because it's 10 plus 2 is 12, 10 minus 2 is 8. So, just by a little bit of math, you can see that both of these rectangles contain exactly the same area. Both have exactly 10 by 2, that's 20 cubits. 20 cubits. At least I think so. Maybe I'm mistaken. Let me see again. Let's make sure that I'm right. What is the area in this slanted rectangle? You can figure out the area by going from this is from 0, 0 to 2, negative 2. Definitely more than 2, because it's the diagonal of 2, so it's 2 times the root of 2. So I think I'm wrong after all, because that's only 2 and this is a bigger value. And then you go, on the other hand, the length of this figure goes from 0, 0 to 12, 8. So you gotta, for that you gotta know the 12 squared plus 8 squared and the root of that. I'll give it to you in a minute. Calculator. Here's my calculator. Hold on a second, please. We get now the root. We want to know the root of 12 squared plus 8 squared. The answer is 76. Well, that's a mistake. Oh no, I gotta do it. It's 12 squared. I'll do it the long way. 12 squared plus 8 squared is equal to 208. The root of that is 14.4. So this rectangle has 14.4 the length, and the width is 2 times the root of 2. 2 times 1.4 is 2.8. So hold it. So I'm wrong. This has 2.8 and 14.4. 2.8, make it a little bit higher, you can see better. 2.8, 14.4. That's much more than just 20. So we see after all that this transformation is problematic. Not like I said before, we have here actually a total different configuration. So we need to know how to manipulate this business here. Actually, to be surprised, it's 14.4 times 2.8 is 40.132. That is exactly double. Surprisingly, it's exactly double the area than the other one. So actually we will end up pushing everything down half its size. So we'll do two things to get the applesauce from table XY to table UV. First we do this x plus y and x minus y, and then we push it down in half because it takes up more room in the second table. So now we'll do just vice versa. We know a point. We see right now a certain point on table B. You would like to know how much is the height of that point, the applesauce in that point, how tall is it? We must first convert this, finding the XY point from where it came from, and then see what is the height at that point of XY, and then slice it into two. Let's explain. Let's assume we have a chart that tells us from each point XY what the height of the applesauce is at that point. So we take here, somebody's interested to know on some random point, let's call it, let's say it's 4, 6. X is 4 and Y is 6. I'm sorry, U is 4. This doesn't make sense. Yeah, it could be. U should be 4. And U is 4 and V is 6. I think it makes more sense. 6, 4. U is 6 and V is 4. So we say let's first figure out from where it came in X and Y. So we do 6 plus 4 divided by 2, that's 5. 6 minus 4 divided by 2 is 1. It comes from 0.51. Now let's see in the chart at 0.51 what is the height of the applesauce. We slice that into 2. This is basically what this whole Jacobian business is telling us. It's telling us how to get the corresponding point on the XY table that matches to this, and the proportion that this transformation caused a certain shift, and how to magnify it or to shrink it. It could be a variable and it could be an exact number. This is what we're dealing with. We're dealing with with two things. First of all, which point do we have to mimic? The height of what point in the X and Y. So we need to take this UV point and see where this came from. What's the mother of this point on the X and Y? Because we have to mimic that point, and to see what is the height of the X and Y, at that point to know what will be the height, or what is the height on the UV table at this new point. So we have to know what the mother of this point is. Then we're not done yet, because if the UV table is a bigger table or a different distorted shape, we must push it or work around with it. This is the transformation, to understand how each box, it jumps over to UV, and also it changes its size. That box that was an X and Y expands or shrinks, it does all kinds of weird. That's how it gets back to the UV table. When we know that, we can tell you exactly the amount of applesauce on the UV table at a certain point. If it shrinks, then you gotta take that number and shrink it. If it expands, you have to expand it. And sometimes the shrinking and expanding is not a constant. It is something that is dependent on the UV, in other words, dependent on the XY, really, because the way it was transformed from the XY was in a certain manner that it has to shrink to a certain degree. For this to understand, we have to have concrete examples, but we'll not do it right now. Thank you for listening.